Hello everyone, Jake Peters from Hapeman Electonics here to talk about our brand new single battery load tester for 500 and 650 amp hour locomotive batteries. This video is going to explain the basic usage and operation of the battery load tester, as well as the basic safety concerns and connections to the battery itself. You can see up from the back of the tester that this is a mobile dolly design meant to be wheeled right up to the locomotive when it's in the shop to test the batteries. You can see on the back there that there are a couple of hooks that hold the test cables that are hooked to the battery for testing. Here in our shop we have a basic 650 amp hour battery that came out of a locomotive. Now this is a pretty old battery, it's not in the greatest of health, but I'm going to show you how to hook up the battery load tester to it and run the system to see how good the battery actually is. I've unraveled the test cables from the back of the battery tester, and I'm going to connect them here to the battery right now. I've got the positive cable here on the positive side. As you know, if you've ever hooked up a car battery or anything like that, you always want to hook up the positive first. Now we're going to bolt these connections right to the battery. You don't want to use welding clips or anything like that, although you might be tempted to, because during the load test, if any of those connections wear or they don't connect quite well, you could have all kinds of problems, including at minimum a bad load test, and at worst you could cause sparking, arcing, or even some kind of a fire. So we always recommend that you have a good lug that's clean off the tabs, and you bolt the thing right to the lug whenever you go to use it. Now one of the things we also recommend, especially if you're gonna leave this battery in the locomotive while you're testing, is to use one of our safety sleeves that goes on top of the battery terminal when it's connected. So I'm gonna actually show you how to hook up the positive side using the safety lead that we supply with the battery tester. So what you do is you slip the cable right through the safety lead like that, and then you can let it slide down if you want. And then we're going to go ahead and bolt this lead right to the battery. I'm not sure if you can see this on the video, but it shows right there on the lead a plus sign for the positive cable, and the other side will obviously be marked minus. Okay, now that my test cable is nice and tight on there, I'm going to slide the battery lead safety cover over it just like that. And what that will do is, if for whatever reason you get close to the steel frame of the locomotive or anything like that and you accidentally short the common to the locomotive frame or anything, you won't accidentally drop a lead or something and potentially cause a catastrophic issue, or a thermal event, if you will. So now let's go to the battery load tester and we'll power it up and we'll see how to run the test. Okay, so here we are at the front of the unit. I'm going to show you how to power this thing up and run a test. Here on the front we've got three controls. We've got the power switch to turn the unit on and off. We've got the e-stop button, which will allow you to perform an emergency stop on the system if necessary. And we've got a physical start button. This unit runs on 24 volt battery power, so you don't actually have to have it plugged into wall power to operate it if the batteries are charged. If the batteries are dead, you'll need to plug it in the wall to be able to run it, or you need to plug it in and let it charge all night, because if you just plug it into the wall, the batteries will charge up, and then the next day you should be able to unplug it and wheel it out into the yard to be able to do your thing. So what we're going to do is we're going to turn on the unit here. We're going to wait a minute for the system to power up. It takes a minute for the HMI to get going, but in a second here you'll see the control screen pop right up. And there we go. So right on the original control screen here, or the main control screen, you can see we've got a kind of a bunch of information on here. And most of it is self-explanatory. You've got obviously your title bar up here. Up here in the upper right-hand corner, you've got the battery capacity that's left on the internal 24-volt control power. So you'll see that kind of go down to 0 as the thing is draining of power. And obviously, if you have it plugged in, there'll be an indicator that shows that it's plugged in as well. Right here on the left-hand side, we've got the live battery reading coming off of the battery that we're connected to, so the one that I just recently showed connecting. And then next to that, we have a indication of the results of the most recent test that was run on this battery. And as you can tell, I haven't run any tests since I started this up, so this value is actually retentive and will stay in the system if you power it off and power it back on. So let's say you test a battery and then you turn it off and you run across the floor, you go on break and you come back and you want to figure out what the last test result was because you forgot to record it or whatever. That information will be in there for you. And it shows the low point of the battery volts when it's loaded and what the low point is of the current draw that the battery is pushing through the load in the tester. And it will give you a determination of whether or not that is a good or bad battery. And over here, I didn't mention, there is a grid temperature reading, which is a temperature reading around the load resistor that is in this system. And it's basically just an indication to let you know if things are getting too hot. So a couple other things on here is there's a run test button that you can use instead of the start button, the physical start button in front. And there's also a settings button that can be used to adjust various settings of the system. The settings button will almost never be used by a standard operator. It's mostly for maintenance personnel, and we'll get to that in another video. So for now, what I'm gonna do is I'm gonna actually use the button on the screen to run the test so that I can show you that if you use the button on the screen to run the test, it'll actually bring up just a short little instruction on how to actually use the unit. And it's basically telling you, hook the positive lead up, hook the negative lead up, don't use regular clips or anything, make sure it's bolted on, make sure all personnel are standing away from the unit. And then at this point, you can either press start test or you can press cancel. If you press cancel, it goes back to the main screen. But if you press start test, you'll see that it'll actually run a load test. And right here is the test screen. What's doing is it's telling you that it's setting up to run the test. You've got the live voltage and current reading, the live grid temp, and you'll see that it's actually graphing the volts and the current as it's running the test. And you see as it's being loaded, you can't really see in the video, but there's a bright flasher on top that's flashing to let everyone know that it's loading, and you can see a live reading of it loading the battery. The volts are dropping, the amps are going up, and then after 15 seconds, the load goes away and it goes into a cool down area, or a cool down sequence. And you can see down here right away it says that the battery failed because the battery didn't have enough health or was not charged well enough and fully enough to be able to run the test. Typically you want to run this load test on a fully charged battery. You don't want to run it on one that is completely drained because obviously you're just going to get a bad test if that happens. So what this is doing right now, you'll notice that it says reduced cooldown on here. What that means is that for the first battery that you run, it'll have a reduced cooldown of 1 minute. And then after that, it will require a full-length 5-minute cooldown. And the reason why we do that is so that typically an operator is going to wheel this up to the side of a locomotive which has 2 batteries on it, and they're going to want to be able to test both of those batteries back to back without having to wait 5 minutes in between for the cooldown sequence. So what we do is we just let you run 2 in a row with just a small 60-second cooldown at the beginning, and then after that you have to wait 5 minutes before you can run the next test. You can see that after the load test it goes right back to the home screen automatically, and it's now updated the most recent test with the one that we just ran. So obviously this is not a good battery. The volts are too low, the amps are too low, it just has too low of a battery resistance so that it's dropping too much whenever we're loading it. So let's say you disconnect it and you hook it up to the second battery on the locomotive, and you go to run the test again, which we'll just go ahead and do. Now this time, I'll just go back to the main screen and I'll use the start button to run the test. And you'll see when I press the start button, it just bypasses the instruction screen altogether, and it just jumps right into the test sequence, which is totally fine. I mean, it's just, obviously, if you've been running this thing for a while, you don't need to read the instructions every time, and some people don't want to use the touch screen, they just want to use a physical button. So you see we're running another load test here. It's loading it again. You can see our grid's starting to heat up a little bit. And you can see the grid temperature's not that hot. That's why we allow you to run a couple of batteries back to back. And now, this time you'll see, because it's the second battery we run, instead of saying reduced cooldown, it says just cooldown, and the cooldown time is now 300 seconds or 5 minutes, as opposed to the reduced cooldown, which is only 60 seconds. So now you have to wait 5 minutes because you've tested 2 batteries, and then after that it'll let you do a reduced cooldown again, and then it'll make you wait 5 more minutes, then it'll let you do a reduced cooldown. One thing I will say is that if you happen to shut this thing off while it's in cooldown, whenever you turn it back on, it will go back into cooldown to make sure that the load resistor is cool before you run the next test. Now, if you shut it off and you wait, 3 hours, and then you turn it back on, it won't go back into cooldown because it knows it knows the real time and date, so it knows that it's been long enough that it won't have to go back into a cooldown. But another thing that I want to show you is if, let's say you're in a test screen like this, you can click the home button to go back to home, and what it will do is it'll get rid of the run button, and it'll bring everything up in red, and it'll show up at the top here what the current test sequence is. So this is explaining to you that the test is still running in the background. And by test, I mean the test sequence. The cooldown is part of that. So if you went back to the home screen during the setting period or the testing period, it would say setting or testing up here, and then it gives you obviously your countdown for the remainder of that step. In this case, the cooldown is waiting for 300 seconds. And at the end of this, all that will go away and it'll go back to the regular screen saying, Hapeman Load Tester. But if you're in the screen and you want to go back to the test screen with the graphs and stuff, you can just press this yellow button and it'll go right back to the test screen. Or you can stay on the home screen. But either way, you've got to wait for 5 minutes until this cooldown is done and you can run another test. One last thing that I wanted to show you was on the side of the unit here, there's 3 connectors. There's a power connection, Ethernet connection, and a USB connection. As far as the general operation goes, you'll never use the Ethernet connection or the USB connection. Those are specifically for updating software and doing stuff that typically is only going to be part of the maintenance program. But if the batteries are ever dead, or if you just want to run it while it's plugged in, you can use a standard IEC 110 power cord for this, the same type of power cord that you would get with your computer, your TV, your computer monitor, anything like that. It's going to fit in here and you plug it into the wall, and when it's plugged in, this green light will turn on to show the power is being supplied to the charging system inside, which should be charging up the 24-volt batteries. Alright everyone, thanks for watching. Again, my name is Jake Peters from Hapeman Electonics, and you've been watching a video on how to use our brand new single battery load tester for locomotive batteries. If you want more information or you need to contact us about your unit, you can contact us at hpelect@hapeman.com by email or by phone at 724-376-2239. Thanks for watching.